This is ScoreBooster chemistry that is aiming to provide solutions to some problems as far as WAEC, JAMB and NAPTEB exams, even ECO are concerned. Our topic for today is going to be on discussion of oxygen as a member of a non-metal group that we have been talking about for quite some time now. Last time we talked about nitrogen, where we said nitrogen is a member of non-metal. It belongs to P block and it has 3 lone pair of electrons, so it can react with these three lone pairs of electrons, either with itself, with other nitrogen atom, to form nitrogen compound. That is when we have 3 bonds. Or it can react with other compounds like hydrogen, like oxygen, to form some other compounds. So it has some properties like this this unpaired electron. It depends on the way it reacts. If after the reaction there is unpaired electrons, then the compound form should be, as in we expected the compound to be paramagnetic and to be colored. It is only in nitrous oxide that we have the exemption. That is when the gas is colorless and still it has unpaired electron. That is not where we are going today. Today is going to be on oxygen, some properties of oxygen, some reactions that oxygen can undergo, some preparations of oxygen, some compounds that can be formed from oxygen, and their properties and their uses. We are going to examine these and the common ones in the next few minutes of this lecture. This is our periodic table that we are quite familiar with, and this is the location of oxygen. It's the 8th element of a periodic table. Our interest today is not going to be writing the electronic configuration, because we have talked about that. We know how to write it, and that is not our aim for today. Our aim for today is going to be the in-depth study of oxygen. We know that oxygen is a constituent of atmospheric air. In fact, it is like almost 21% by volume of air. And apart from constituent of air, in the earth crust there are many compounds that combine with oxygen. It makes oxygen to be the most abundant element on the earth crust. Even the 50% of the mass of earth crust consists of oxygen. This is not atomic oxygen or molecular oxygen in isolation, like we said, because somebody will ask, but you said it's 21%. If everything is being put together, where oxygen is appearing, whether it's from the compound, standing alone, or from other things, everything is put together, oxygen is 50% of the mass of the earth crust. What we're trying to say is this: there are many compounds in the earth crust. There are many holes in the earth crust, like acetylenides, like ion in the earth crust, like water, like all those peroxide silicon compounds. If you count all the oxygen by mass that is in all this, we are going to see that it is 50%. Even after it, because I remember we said it last time that after oxygen it's going to be silicon. Silicon is the second most abundant element in the earth crust apart from oxygen. So oxygen is 50% alone, but it is not only occurring, it is in combination with other elements. Oxygen occurs as an oxygen molecule, and sometimes there are times that there is going to be formation of what is called ozone. We are going to talk about ozone in this lecture, but later. In the Earth atmosphere, it forms about 20% of the mass of air. That I said is 21%. So sometimes they approximate it to say it's 20%, sometimes it's 21%. What we are trying to say is that there is almost about 20% of the mass of air that is made up of oxygen. by mass. If you write the formula of water, H2O, it is by 89% of that is oxygen. We have talked about how to calculate the percentage by mass of each of the elements in the compound. It's just a matter of putting 16 all over 18 multiplied by 100. 16 is the mass of oxygen that is present in water, 18 is the mass of water. So if you do that, you're going to get something around 89%. So let's try to visit some properties of oxygen. Oxygen is a gas. Yes, definitely. It is in the atmosphere. Definitely it is colorless, because if it were to be colored, then we won't be seen. It will disturb our visibility. So it is colorless. It is odorless. Yeah, because we are breathing in oxygen. I don't mean it has odor. Either the odor is offensive or not. We will not be able to breathe in like that. It is tasteless, definitely. That is at ordinary temperature. It is tasteless. It is slightly denser than air. Yes, because oxygen exists as a molecule. In the air, oxygen exists as atom. So if you have 100 grams of air, so in that 100 grams of air, since oxygen is about 20%, so we have 20 grams of air. So now 1 mole of oxygen molecule is 32 grams. That's why we say it is slightly denser than air, because somebody will be asking that, but oxygen is in here, why is it that oxygen is still denser than air? So that is the explanation. It is soluble in water. But just slightly, it is not as soluble as the hydrogen that we talked about the other time. Almost 43 grams of oxygen, if I can remember, it's almost 43 grams of oxygen in 1 liter of water. But this level of solubility is important to aquatic lives, because in the water there are some organisms that are living there. If there is no level of solubility at all, they won't be able to survive it. So that level of solubility that is there is able to make them, to sustain them, so that there is balance in their ecosystem. How to prepare oxygen is, as we know, oxygen is present in here. So how do we do that is to separate that through distillation. Distillation here is not ordinary distillation. It is fractional distillation, because the boiling point of all those components of here are close. So fractional distillation is the best method to do that. How do we do that? When we have oxygen, when we have air, we collect air in a particular container compartment. We increase the pressure. After increasing the pressure, the air is liquefied. After liquefied, the temperature goes up. When the temperature goes up in the fractionating column, all the components will be separating from each other. So oxygen that is needed will now be collected. That is how to separate oxygen. Because it is denser than air, it is collected by upward delivery. The other route is the electrolysis of water. We have talked about electrolysis before, and you know that if you have electrolysis, since we need oxygen, then we go to the anode. That is where the electron is lost. That is what didn't take place at the anode. So the electron is lost at the anode, then oxygen ion turns to oxygen gas. So oxygen gas is now collected at the anode. That is another way of collecting oxygen. These two methods, they are very, very pure methods to collect oxygen, whether in the laboratory or in the industry. Oxygen is essential in combustion process, because oxygen supports combustion. So they use oxygen in combustion process. And again, we want to be very, very careful with this when we are handling oxygen as a for combustion, because oxygen can, as in to a very large extent, can explode if it is not being taken care of very well. So to do that, there are times that nitrogen that is not reactive is always used as a control that is being mixed in the system, so that the system will be in a controlled environment in such a way we will not have something like any explosion. Some plants and animals, plants and animals also use oxygen from here in respiration. Yeah, plants and animals need energy for survival. They need this energy now comes from burning of food because oxygen supports combustion now. This burning of food through respiration now release carbon dioxide and water, then plus energy. That energy is what organism is needed, whether it is plant or animal, to move around. So this carbon dioxide, it is now what that is being released into the atmosphere. That is after respiration. We are taught that human being breathe out carbon dioxide. So this carbon dioxide is now released into the atmosphere because of the reaction of carbon dioxide and water with the chlorophyll of plant, catalyzed by the energy of the sunshine. Then plants are able to manufacture their own food. So in such a way, there is balance in the ecosystem, such that what human being, what animals and the rest, human being and the rest of other animals, what they breathe out, it's what the plants use as a source of manufacturing food. This food is now being consumed by the animal, by human being and other animals. Then through respiration again, this food is now burned. Animal has that energy, then CO2 is released. Through that, there is going to be a continuous cycle. So the waste of one is equal to the raw material or the food for the other one. That is how Almighty God has been able to keep the level of oxygen and CO2 in the ecosystem to be balanced. In the chemical industry, they employ oxygen as an oxidizing agent. Yes. How do they do that? In the extraction of metals, in extraction of other things. If Ozone, example now, in a steel production, we want to extract steel, and we thought that iron does not occur as an elemental ion, because I remember I explained that the reaction of particular metal dictate how it will exist in the earth crust. It is only gold and like silver that are not as reactive like that. Not electrical reaction like this, that are not as reactive, that exist as an element in the earth crust. So because some other elements like iron now, like copper, because they exist with a company of other elements, so oxygen is being used. In this case, if we have steel, you remove carbon from the oxygen. So how do we do that? When you bombard it with oxygen, carbon will react with oxygen to form CO2. CO2 is released into the atmosphere. Then we have our own ion. That is it. Another one is in the metal fabrication. Oxyhydrogen and oxyacetylene flames. During this reaction, oxygen reacting with them makes the temperature to build up, such that the large amount of heat that is generated is being used is enough to melt the metal, and the metals are able to be able to we can cut the metals and mold them, weld them in a way that we want through these iron elements of it. So oxygen is also very important in metal fabrication. Another one is the liquid oxygen that is important in the space for life in space. People that goes into the atmosphere, the astronauts, people that goes into the atmosphere for study. So they use oxygen as a gas. What they breathe in when they are there, because oxygen is not there. So that is what they use to support their life in the hop. So in the photosynthesis and respiration, as I've explained, oxygen is being used there because oxygen is what is being used in respiration. Then in the photosynthesis, oxygen is liberated in the photosynthesis. So those are the things those are the areas where oxygen is being used. We can see it is in nature, we use oxygen. Then in science also we use oxygen. There are some reactions that oxygen can undergo. So let us start with reaction with some elements. Sometimes oxygen reacts at room temperature. Sometimes you need higher temperature to react with oxygen, especially when you have metals that are above uh, copper electrochemical series. So there are times that you need a higher temperature to make the reaction to drive into completion. But also, oxygen does not react with some noble gases and with some halogens. Because noble gases, the shell is complete, we don't expect the noble gas to be reactive. So it is not an exception that oxygen is not reacting with noble gas. Again, with halogens, oxygen do not react with halogens. So the more active metals, they form peroxide or super-oxide. What we are trying to say is this: there are some metals that are very active, like sodium, like potassium, like calcium, like magnesium. They are very active, so they form peroxide, like sodium peroxide now, like potassium peroxide now. They form other superoxide. But less active metals, they give they give oxide, like aluminium now. You hear aluminium oxide. That is reaction with oxygen. Aluminum oxide. Reaction with oxygen cannot form aluminum hydroxide, so it is form aluminum oxide. So the more reactive an element is, the chances are that you have peroxide and superoxide formation. But when you have less reactive metals, then we have that metal oxide. Sometimes when we have in a compound that it is possible to have oxidation, when oxygen can react to oxidize one of the elements of that compound, then oxygen reacts. In the example is the reaction of oxygen with hydrogen sulfide. In this case, we can actually oxidize the hydrogen in this case. So oxygen reacts with hydrogen sulfide to form water and sulfur for oxide. Another one is the oxidation with some other element or other compound like carbon monoxide, nitrous oxide, like phosphorus 3 oxide. All these elements, when they have lower oxidation state, then oxygen is there to increase the oxidation state. In this case, carbon is oxidation state of 2. So reaction with oxygen will make the oxidation state to be equal to 4. That is another oxidation. This one is oxidation number is 2. So reacting with oxygen will make the oxidation number to be equal to 4. This one, the oxidation number is lower, like 4, 6 times 2, 3. So to make it higher, so reaction with oxygen will make it higher. That is what we are trying to say, that it depends on what the aim of reaction is. But generally, on a general note, oxygen reacts with compounds in order to either oxidize one or two of the elements of the compound, or to increase the oxidation state of the compound. So let's talk about oxides. Those are the compounds formed from oxygen. So to have oxide now, we can, by heating, form some oxide, especially those oxides that are not stable to heat, like the carbonate of calcium, the carbonate of ammonium, that are not stable to it. So when there is heating reaction, there is going to be elimination of carbon dioxide and calcium oxide if we're using calcium carbonate. So in this case, the yield of calcium oxide and calcium oxide is not much. But if you want to increase the yield, it's just a matter of letting the CO2 to escape. When the CO2 escapes, then the yield of carbon oxide is going to be as close to 100. Another one is when we have bromide, that is aluminum hydroxide. This aluminum hydroxide can be heated under a high temperature. Then there's going to be a removal of water, that is a dehydration reaction. So when we have a dehydration reaction like this, we can form another oxide of a metal, that is alumina. And apart from that, when we have a salt, like we have a salt in calcium carbonate here, when we now have a very reactive metal, I mean the sort of very reactive metal like sodium nitrate, now it is not easy to decompose sodium nitrate, because if it's calcium nitrate, now we can decompose calcium nitrate in this case and form calcium oxide and NO2. But sodium nitrate and potassium nitrate is not easy. If you want to get oxide of that metal from it, whether it is potassium, now we are going to heat the elemental potassium with it, then the nitrogen is going to escape. That is it. Apart from that, lithium oxide also can be heated with lithium and form. Lithium hydroxide can be heated with ordinary lithium, with elemental lithium, and form lithium oxide. The take-home message here is that if we have a metal whose salt is not decomposable by heat, then you mix that metal with that salt, with the salt of that metal, and heat it. When you heat them together, then they're going to be oxide of that metal. Then group 1 and group 2 metals are not always born in here. This is the reason. If you burn this group 1 and group 2 elements in here, they are very, very reactive. As they are reacting with oxygen, then they will be reacting with nitrogen also. They form oxide and they form nitrate. So it frustrates our effort. The yield will not be enough. That is why they don't do that. Instead of that, they will look for a salt. Like I've said, explained here, they look for a salt and react with the metal with it and heat it. Sometimes, with the assumption of insoluble aluminum oxides, aluminum oxide is not soluble, tin oxide is not soluble, and lead oxide is not soluble. So they react with acid to form salt, because this oxide, they are also bases. They can act like a base because it is just small. If you want to turn this to a base now, just add water to it. But if you are reacting it with an aqueous solution of an acid, then you don't need to add water also, because the hydrogen that is going to be donated from this to form water is always in the acid already. So it is only this insoluble oxide that you cannot react with this one. With any other metal, you can take any metal, hypothetical metal on your own, and react with it. Just make sure you are forming water. And so this is a type of neutralization reaction. They react with water, as I've explained now. They react with water to form hydroxide. Uses of some of the oxide. Magnesium oxide is a very useful oxide. It is used in making firebrick, making crucibles, making furnace lining, and thermal insulation. This is because of stability to it, because it is very, very stable. You can see all this usefulness. They have something to do with heating. So because this is very stable to it, they are being used in these applications. Calcium oxide is an inexpensive base used in chemical processing. It's very, very, because even in agriculture, this calcium oxide is used like a quick lime. If you want to form a slake lime, you just add water to it and form calcium hydroxide. That is a slake lime. So it's very, very useful in chemical processing and in agriculture. Alumina. This alumina is they call it conundrum. This conundrum is a very hard substance. Because of this hardness, it's being used as an abrasive material, abrasive in grinding and polishing. So that is one of the uses of this alumina. This zinc oxide is a very important oxide of a metal, also useful in white pigment of paint. White pigment of paint, because let me explain how you can get this white pigment. So if a house is to be painted, there are times that they use white something thin white film, because before they put the intended paint on top of the house. So that white that they used to put to prepare the wall of the building is made of zinc oxide. Another one is in medical practice, when zinc oxide is being used as an ointment in case of skin disease. Sometimes they use zinc oxide as an ointment. Another one is small kids. They use powder for them, or some white powder. They use it for them when they are having skin rashes. So this is another example of where they're using it in medical practice. So skin rashes, they use zinc oxide with it, so it removes the skin rashes. Especially, I'm very sure of that powder. Another compounds of oxygen is ozone. Ozone is an allotrope of oxygen. What allotrope means is when you have element in the same chemical but in other physical appearance. That is ozone. So this ozone is an allotrope of oxygen. You can see it is oxygen, but 3 atoms of oxygen combined together. That is ozone. How do they prepare ozone? Ozone is prepared when dry oxygen is passed between two plates that is charged electrically. And of course, this compound has odor. The formation of ozone from oxygen is an endothermic reaction because we said it is electrically charged plate. When you have two plates facing each other and oxygen pass through it, there's going to be systemic transformation of oxygen into ozone. This is the reaction. When you have a plate, the oxygen is passed through it, there's going to be rearrangement of this to form this. This is ozone is an endothermic reaction because you can see this high amount of heat, 297 kilojoule of heat. The sap color associated with sparking electrical equipment is due in price to ozone. What we're trying to say is this: sometimes if you are close to where they are using something like a spark, or there is a spark in the wire, you hear you perceive some smell. That smell is because of the reaction, the rearrangement of oxygen in the atmosphere to form ozone. As a result of the spark, the heat generated by that spark causes that oxygen to rearrange to form ozone. So that is the odor we perceive that time is the odor of ozone. Naturally, we have layers in the atmosphere. We have the troposphere, we have the stratosphere, we have the ionosphere. In the stratosphere of the stratospheric part of the atmosphere, the earth crust, that is where we have ozone formation, and that is because the ultraviolet light from the sun acts like a plate. In this case now, there is a very high amount of oxygen in that stratospheric part. Then there is ultraviolet ray coming from the sun, also high amount of heat in that case. So when it strikes oxygen, there's going to be rearrangement. That is when ozone is formed. This stratosphere is almost around 10 to 50 kilometers above this Earth's surface. In the troposphere, that is below that stratosphere, if ozone is formed there, is going to be reduced visibility. That is the genesis of photochemical smoke. It reduces our visibility. But there's ozone in the stratosphere is very useful for us, as we are going to see now. This ozone that is formed in the stratosphere, it is form of a barrier, a shield that prevents the scorching heat from the atmosphere to burn our skin. It absorbs this by chemical decomposition reaction. This is the ozone in the atmosphere. The ultraviolet light that is coming strikes this, then forms this atomic oxygen and this oxygen molecule. Because this is atomic oxygen, it is not stable. It reacts very fast. Then it quickly attaches itself back to one oxygen molecule. Then it forms back the ozone. So invariably what we are trying to say is this: Almighty God has made it in such a way that the ozone layer will decompose and immediately readjust, as in recombine again to form another ozone layer. But what the job is doing is to trap the energy of the sun from reaching us directly like that, because that energy is so much that if it reaches us like that, there is a risk of high frequency of cancer. That's what we are saying. So the ozone layer will absorb the light, just release small to us, absorb the light, decompose, form back again, but it won't release that amount of energy. So it's in a way it's protecting us from the high intensity of energy of the sunlight. How ozone is used. Ozone, the use of ozone is generally on its reactivity with other substances. If ozone can react with other substance, then ozone is very, very useful in that aspect. Now, in bleaching agents, like if you want to remove oil or waxes from other substance, ozone is being used. This is because it can oxidize those substances. Reacting with them oxidizes them, then converts them from the colored substance to colorless compound. So if it's oil now, ozone reacting with oil, it can form some other some other colorless substance that won't destroy our fabric. So that is one usefulness of ozone. Another one is in disinfection. When in place of chlorine, we can use ozone. We can use ozone to treat our water, to disinfect it, to do other things. Depletion of ozone. Yeah, this is another problem in the world currently. As we are growing, we are using some basic things that makes life easy for us. One of them is the refrigerators. Another one is chemicals that we use as a sprayer, like maybe for killing mosquitoes or in the agriculture. All these substances contains what is called chlorofluorocarbons, that is freon. That is the trade chemical name. The trade name is freons. So these chlorofluorocarbons, as the name implies, contain chlorine. When these are released into the atmosphere, the energy of the sunlight breaks it. If it breaks it, we have release of chlorine. This chlorine now, it is atomic chlorine. The chlorine will now attack the ozone, breaks the ozone into oxygen and one compound that contains chlorine and oxygen. So it has reduces ozone to oxygen. So these chlorine and ozone compounds, chlorine and oxygen compounds, are not stable. They decompose again. This one atom of chlorine that has done a first damage will go back to attack another molecule of ozone. So in that case, there is removal of ozone from the ozone layer. Although currently there has been some environmental regulations on how to minimize the release of CFC, because it's actually causing enough damage, more than enough damage we have been causing in the atmosphere. So that is what we have for today. Before we go, let us try to have some review. Oxygen is a non-metal that is useful for existence of plants and animals. in respiration, in photosynthesis and others. It is mainly produced from fractional distillation of liquid here. And another important route is the electrolysis of water. It reacts with some metals to form oxide. Sometimes it forms hydroxides, that is if water is present. Sometimes it forms peroxide, that is if that metal is highly reactive. It can also react with some compounds in redox reaction, like the reaction of oxygen with hydrogen sulfide that we talked about. The reaction of oxygen with carbon monoxide, like with nitrogen oxide. That is, in a way, it is based primarily on oxidation reaction, whether it's going to oxidize one or more of the element, or it's going to increase the oxidation number of the element. Thank you very much for listening. God bless you and really good. Our next discussion, by the grace of God, is going to be on some other giant oxides of other giant oxide like peroxide, like super oxide. Thank you very much for listening. God bless you.